modern world, operation of all devices that surround us depends on electrical power. Computers and server rooms, household and specific devices, illumination, all these need an electric current. If it disappears, houses and whole districts lose power, including equipment that should work constantly. For example, in hospitals, banks and organizations that control municipal services. In case of emergency, when power is suddenly cut, uninterruptible power supplies will help you.
GE has a state-of-the-art position. We have been the first launching new technologies and new product. For example, the first digital signal processor controlled UPS.
Uninterruptible power supply, or UPS, is an external device that protects equipment when power fails. As soon as electric current disappears, UPS automatically feeds the load from the battery. Normally, the UPS supplies power facilities directly from the AC mains. It works as a conductor. An electronic module similar to a computer motherboard controls the incoming voltage quality. It can be called the brain. If the mains voltage fails, UPS starts supplying the load from the built-in battery. Load here means devices that consume electricity. All UPS models can be divided into three large groups: passive, line interactive and double conversion UPS. Passive type UPS models are the simplest devices. They consist of a filter, which reduces the noise input voltage. A rectifier converts AC power to DC power to charge the battery, while an inverter converts the DC back to AC to feed the load if electricity fails. Line interactive devices also have an auto transformer, which eliminates voltage surges without switching the device to offline operation mode.
We have launched the TLE UPS, which is the best efficient UPS in the world, with 97% efficiency, double conversion.
The most reliable UPS devices are double conversion ones. Unlike the first two types, the inverter there operates constantly, giving stable AC power without noises and splashes. In such devices, there is additional insurance, automatic bypass. This is a separate bypass line, which can feed objects directly from the mains if the inverter suddenly fails. If we imagine the path of electricity in a circuit where there is power, emergency generators and electricity consumers, the uninterruptible power supply would be a key element in the chain securing the entire system. It's perhaps one of the most important inventions since Edison's light bulb. But to whom do we owe its appearance? Switzerland, a country famous for its banks, watches, and uninterruptible power supplies. Locarno is a small city in the south of the country. It has a scientific laboratory where, since 1964, uninterruptible power supplies have been developed. The laboratory has changed its name and owners several times. In 2001, it was acquired by General Electric.
When you are at the top, it's even more important to stay on the top. And for this, in GE, we have many internal processes that can help doing this. Every year, we conduct a multi-generation technology plan where we look at, in the next 3 years, how we can use new technologies in our product lines.
UPS design consists of two stages, electrical and mechanical. First, a UPS computer project is created. This is done by an electronics hardware engineer responsible for electronic components. Along with the creation of new UPS projects, he also develops new PCB boards and improves existing ones. All documentation on PCB boards is released here, where they choose the best in-class components to create a reliable and powerful product. At this stage, the UPS is approximately 30% ready. The idea is to present it to the customer. If the project is approved, all the drawings should be completed and a prototype should be built. This system is called fast work. It helps to save time and produce only actual products. The mechanical part of UPS design is performed by a mechanical design engineer who incorporates the electronic UPS project into a real product. At this stage, he compiles the bill of materials, contacts suppliers and works with different departments on all activities related to the mechanical structure of UPS units. Before the UPS model or prototype goes into production, it should pass a series of tests in specialized labs performed by qualified and experienced staff. The first test is on a sub-assembly stage. Such components as wires, PCBs and main modules should pass parametric tests. These tests last up to 40 minutes. All components are tested under a low voltage of 24 volts. After assembly, a functional test is carried out which includes a startup procedure, scanner reading of key components and other manual operations. This test takes up to 6 hours. After the equipment is successfully run and checked, the test starts. It's done partially with a full load. This is a 5-hour test. It's worth mentioning the test is fully automatic. With the help of a computer, different events that may happen in the field are simulated. This stage lasts from 25 minutes to 4 hours, depending on the UPS model. One of GE Production's advantages is a customer acceptance test, which can be carried out in the customer's presence. A standard protocol includes measuring efficiency, input and output harmonic distortion, overload, step load tests and a short circuit test. In the overload test, UPS should stand a load 1.5 higher than normal for a minute. Moreover, on request, GE can also perform extra tests and provide a tailor-made protocol to satisfy customer expectations completely. A non-linear load burning test and component failure simulation and a connectivity demo are good examples of activities typically required. As tests require a lot of electric power, there's a special room at the factory which feeds devices under tests. The total energy stored in the battery room exceeds 1.5 megawatt hours. PCBs and other components are checked under high temperatures. They are put in an oven and heated up. Ovens are used to evaluate GE product performance in different conditions. They accelerate the aging of the products under development, increasing ambient temperature of the core parts of the units. GE evaluates the design margin exceeding normal operating conditions, ensuring the product can withstand conditions beyond normal working boundaries. They stress components or parts to confirm performance of components supplied by third parties to be used in GE products and for troubleshooting. The average UPS life cycle is 10 to 15 years. During this period, the device undergoes maintenance several times. After 2.5 years, the cooling fan is changed. After 5 years, the battery. After a further 2.5 years, the cooling fan is changed again. The Locarno lab has a special warehouse where spare parts are stored. Some 4,000 different part numbers make up the stock, including parts at least 10 years after the last production build. It supports the local Swiss market. The rest of the world is supported by a factory in Poland. UPSs are connected to a remote monitoring system that works constantly. This is the UPS Remote Monitoring Center, where GE utilizes the iUPS Guard monitoring system and UPS installed worldwide to ensure systems are operating properly. Reports are periodically delivered to customers to share system performance. When UPS generates an alarm, it immediately reports to the monitoring center, where engineers investigate system conditions and, when necessary, take appropriate action. With the iUPS Guard monitoring system, GE integrated several intelligent algorithms based on mathematical models that focus on preventing alarms or system failures to ensure operating conditions and 100% uptime. UPS design is just one of the factors that determine UPS reliability. Other important factors are the quality of components and assembly technology. The factory producing UPS is 850 kilometers from Locarno, in the Polish town of Bielsko-Biała. Covering more than 11,000 square meters, it's one of Europe's largest UPS factories. The assembly shop consists of 3 lines. One line produces up to 10 UPSs a day, about 300 units a month. Production capacity depends on demand, a factor that is constantly monitored. The quantity of UPS for production is set based on this data. The plant employs 120 people. Future UPS components arrive at the assembly shop as sets of parts and assembled modules. First, power bridges and associated units responsible for UPS efficiency are installed. Then static bypass modules are fitted. These feed consuming devices in case the inverter fails due to voltage drop. All UPS parts have barcodes. They carry encrypted information about who assembled the UPS, from which parts it was assembled, and even how much time it took to assemble. This data is stored in a database. In case of any malfunction, it's possible to detect the defect and repair the UPS under warranty. Different modules are fitted in the UPS's body. Its separate parts are linked up, rather like parts in a kid's construction set. The control board goes in last. It's the UPS's brain managing the operation of all modules. The UPS is assembled. Now it needs to be checked. This is done in several stages. First, a low voltage test. A small voltage is applied to the UPS to check the connection of all joints. The UPS is then switched to the mains with standard voltage parameters to see how each separate module performs. If all modules are okay, the UPS is connected to the computer control unit. It simulates overvoltage and voltage drops in the mains. These tests last several hours. Successfully tested UPSs are sent to the warehouse or directly to the customer. A UPS should be handled without batteries and strictly vertically. If you put the unit on its side, heavy modules inside the UPS could fall from their fixings. Therefore, a UPS should be put on pallets that have a layer of polyether foam to counteract vibration. Transporting is an important stage. The weight of a single UPS unit can be up to 800 kilograms. The center of gravity is in the middle. If you tilt the UPS more than 30 degrees, it may fall. In this case, a unit is sent back to the factory where it should pass all the tests again to prove its operational readiness. To assure producers and customers that nothing happened to the UPS during transportation, there's a special sticker on the UPS with a small ball inside. When tilted, the ball starts rolling, and it's clear that the UPS was transported improperly. In addition, every box is labeled with a dye capsule. If the UPS was subjected to frequent and heavy shaking during transportation, the capsule breaks and the dye stains the sticker red. In a modern world where there are often problems with electricity supplies, it goes without saying a UPS is crucial, particularly in remote areas subject to extreme fluctuations of temperature. In addition to comfort and peace of mind, our safety depends on these devices. Railways, hospitals, banks, data centers all use UPSs to secure uninterruptible supplies of electricity. All processes that need constant electric power are at risk without UPS.